Hey everyone, thanks for tuning in to TestTube Plus. I'm Trace. This is a podcast-style show. We take one episode, we break it into 5 pieces to make it easier to understand for everybody, myself included. I've got some notes down here on my computer, so I'm going to try and split my time between you and the computer, but this week we're talking about the history of science. Feel free to pop in some headphones, put me on in the background. I won't be offended. Yesterday we talked about when science first started, and what the history of science is, and who were some of the early scientists and influencers and big thinkers. But what did they come up with? What is science really? So the definition of science is knowledge based on demonstrable and reproducible data. It comes from the Latin word scientia, which is the intellectual and practical activity accompanying the systematic study of the structure and behavior of physical and natural world through observation and experiment, which is kind of wordy. Essentially, though, it's kind of important. Observation and experiment. Demonstrable, reproducible. Those last two, though, are the most important. Observation and experiment, demonstrate and reproduce. That's science. We want to be able to do it again and again, and we want to see a result. So some things that you need to know when talking about science, in case you haven't learned these yet, there are some science words. The first is the word fact. What is a fact? If you're watching some cable news, it's a little fuzzier, but a scientific fact is an objective and verifiable observation. That is a fact. It's verifiable, and it's observation. Hypothesis is another word you see, especially on the internet. You get that one, and theory, and they're usually confused. A hypothesis is a proposed explanation. It's an educated guess. It's the idea that you could maybe think this is the result of an experiment. The official definition is a supposition or proposed explanation made on the basis of limited evidence as a starting point for further investigation. So if you think of the scientific method, you start with a problem or a question, and then you create a hypothesis to try and answer that question. Then there's a theory, which is kind of a group of hypotheses. If you get a lot of hypotheses together, you can create a theory, which is a description of an occurrence. It can be tested and proven. That's important when it comes to theory. And although it may not have all of the explanations ruled out, it is pretty damn valid. Usually people call out, when they're criticizing it, the theory of evolution. But theory means that we've tested it lots already. We have a group of questions that we've tested and observed and verified. So theory is actually pretty strong. It's not the strongest, though. And sometimes people get theories confused with hypotheses. If you just have an answer to a question or an educated guess, that's not a theory. When someone says, I have a theory, to answer your question, they really mean I have a hypothesis. And that's a problem that we all get into. I know I am guilty of that too. Linguistically, it gets a little shady, but stronger than a theory is a law. These are usually descriptions of natural phenomenon, and they have been proven beyond doubt. So Newton's law of universal gravitation is a great example. Boyle's law, which has to do with the relationship between volume and temperature of gases and things. And then there's the law of conservation of energy, which is, that all energy is conserved. And in fact, that is part of the laws of thermodynamics by which the universe is run. And this is all great stuff, and it explains how things happen, but not, if you noticed, why they happen. Newton's laws of gravity don't explain why gravity. They just explain how gravity. Why is a whole different thing. There are a lot of different types of science. We can break it down for you. You've got natural sciences like physics and chemistry, earth science, life science. You've got social sciences, which are really important and often overlooked. Those are anthropology and archaeology, ways to know about our past and our future. Psychology and economics, ways to know about things that are happening now and what's going on in kind of these, what they call covert processes in the brain that you can't directly observe. You can only observe through their influences externally. And these are outside of natural sciences. Physics and chemistry, those are observable reactions. I can see that and I can test it. Social sciences usually come through mathematics and sampling. Then you've got formal science, which you need to do natural science and social science, which are logic and math and statistics. I was never very good at formal sciences. I was a lot better at the social sciences. There's also this one, and this one always got me when I was younger, and that's applied sciences. It always seemed super evil, like mad scientists were always applied scientists. But really, it's literally the name. They apply scientific knowledge to the physical environment. So think engineering. A civil engineer builds a bridge. That's applying science in a real-life situation. It's almost like the word problem solvers of the scientific community. Also, medicine and computer science. Those are applied sciences. There's also something in here called applied mathematics, which is really cool, and they put it in movies when they want you to just trust that this guy's a nerd and knows what he's talking about. They'll make him an applied mathematics specialist. And it's kind of funny because that puts math in applied sciences and also formal sciences. It's a little bit of a cheat. But applied mathematics is interesting, and I went to the Society of Applied Mathematicians, and they say this is what applied math is for. Airliners, using smarter scheduling to reduce cost of aircraft parking and engine maintenance. And disease spreading in populated areas in the event of a bioterrorism incident. That's using math to try and figure out real life stuff. So cool. But one of those areas of science that a lot of people don't associate with science. You're asking questions, making hypotheses, and trying to answer those questions. Science is huge now. It's everywhere. It's literally in almost every movie. It's encompassing nearly everything that we do. You getting to watch or listen to this show right now is because science has become such an important part of what we do every day. Some computer scientist built this. Some audio engineer created these microphones. These are huge parts of our lives now, but we still don't always get what science can answer and what it can't answer, which is almost more intriguing, I think. So what is your favorite type of science? You can let me know down in the comments. I'll be down there with you talking about it, because some of these I probably don't even know much about. And you can also subscribe for more TestTube Plus. If you didn't watch yesterday's episode, make sure you click here or find the link in the description and you do that. It's about the history of science and how we got to where we are now and the men and women who paved the way, big thinkers and doers. It's really cool. Thanks a lot for watching, and we'll see you tomorrow.